Hello everyone, myself Dr. Deepa Bevingidan. I am working as Associate Professor in S.G. Balekundri Institute of Technology, Belgavi. I am uploading my videos on advanced calculus and numerical methods for second semester engineering students. Today I am explaining module 4, that is infinite series. Before starting actual syllabus, let us take some basic definitions. That is, what is a sequence? Sequence is nothing but an ordered set of real numbers, that is u1, u2 up to un, where u1, u2, u3 and so on un are real numbers. Then what is series? Series is nothing but summation of these numbers. Series, that is summation means adding up of these numbers. That is we denote by u1 plus u2 plus u3 up to un. It is called as series. Now, actually what is infinite series? The word infinite itself says a series which is infinite. That is summation of infinite number of elements. That is u1 plus u2 plus un up to infinity. This is called as infinite series. This series is denoted by summation un. Summation means it is adding up. Now we are going to study these series. What is the nature of the series? And what are the tests for this series? For that one, what are the natures? There are three types of natures for any series. First one is convergent, divergent and oscillatory. When a series is said to be convergent, if we take limit n tends to infinity of that series is equal to L may be any real number, then we say that that series is convergent. If we take limit n tends to infinity of un, then we get plus or minus infinity, then that series is said to be divergent. Oscillatory, when we take limit n tends to infinity of that series, we may get more than two answers, more than two constants. Then it is called as oscillatory series. To test whether series is convergent or divergent, we have two tests. One is Cauchy's root test, other one is D'Alembert's ratio test. Today we are going to study Cauchy's root test in detail and we are going to solve problems based on this test. Let us take Cauchy's root test in detail. So what is Cauchy's root test? If summation un is a series of positive terms, then if we take limit n tends to infinity, un raised to 1 by n. Let us see here. So un is given series. We are raising to the power 1 by n. That's why this test is called as root test. We are taking raised to 1 by n. Then if we find limit of this, we get L, any number it may be. Then we say that it is convergent if this L is less than 1. And series is said to be divergent if L is greater than 1. And test fails if L is equal to 1. So in this method, in this test, first we have to write down un is equal to, then raise to the power 1 by n. Simplify it. We'll get, after putting n is equal to n tends to infinity, we get one number. That number will be compared with 1. If that number is less than 1, then we say that given series is convergent. If it is greater than 1, we say that it is divergent. If we get L is equal to 1, then test fails. This is about Cauchy's root test. Now here some standard limits are there which are used while solving the examples. These are very important. You should know these standard limits before solving the example. So what is first one? Limit n tends to infinity, n raised to 1 by n is equal to 1. Observe here, if here n is there, here also n should be there. Then only we can write directly its answer is equal to 1. Second standard limit is limit n tends to infinity, 1 plus 1 by n raised to the power n is equal to e. We know that value of e is 2.7. It is a direct value. Here 1 plus 1 by n raised to the power n is there. Then only we can write its limit is equal to e. Suppose it is 1 plus 1 by root n raised to root n, then also we can write it is equal to e. Same, that same power should be there. Whatever is there here, no, same power should be there. Then only we can write it is equal to e. Next, third one, limit n tends to infinity, 1 plus x by n to the power n. Here difference between these two is, here 1 is there, here x is there. Then its value is e to the power x. Directly we can write e to the power x. Then limit n tends to infinity, log n. It is always 0. If we write log n to the power minus 1, then also it is 0. Limit n tends to infinity, a raised to n is equal to 0. Here a is greater than 1. Then sixth one, limit n tends to infinity, 1 by n is equal to 0, because 1 by infinity it is 0. Last one, limit n tends to infinity, n of n is equal to infinity. So these are very important. Now let us solve problems on Cauchy's root test. Before that, what are the steps to be followed? First, always write down given series un is equal to, then raise to the power 1 by n, that is un raised to 1 by n, then simplify. After simplification only we'll take limit n tends to infinity, because it is a definition of Cauchy's root test. We test limit n tends to infinity of un raised to 1 by n. So then take limit, evaluate. Before evaluating, you should know the standard forms of limit, which I have explained now. Then we have to write down conclusion based on the answer, that is based on L. So now we'll take one example, that is summation n is equal to 1 to infinity a raised to n square x raised to n. What is the first step? Always write down un. So solution, first we'll write what is un here. Un is a n square x raised to n. We'll go according to this only. Then raise to the power 1 by n both sides. So un raised to 1 by n, a raised to n square, x raised to n, 1 by n. Then we have to take this raised to the power 1 by n inside. So this is the first example. So I'll write each and every step in detail. A n square into 1 by n it is, into x raised to n into 1 by n. I am taking this 1 by n inside. What will get here? 1 n gets cancelled. So a raised to n. Here n gets cancelled. X. Now simplification is over. Next take limit n tends to infinity. So limit n tends to infinity, un raised to 1 by n is equal to, x is free from n. So I can take it outside. X limit n tends to infinity, a raised to n. As we have studied, what is limit n tends to infinity, a raised to n? Here a is less than 1, it is given. So its answer is 0. This one is, it is a standard form. So it is 0. X into 0 is equal to 0. Whether 0 is less than 1 or greater than 1. It is less than 1. So as per the Cauchy's root test, so 0 is less than 1. So summation un by Cauchy's root test, summation un is convergent. So this conclusion is very important. Here marks will be distributed as, if you write un raised to 1 by n, you will get 1 mark. Simplification 2 marks. Taking limit 1 mark. Evaluating 2 marks. And writing conclusion 1 mark. In this way marks will be distributed. So this is first problem on Cauchy's root test. Let us take next example. Okay, second example, that is summation n is equal to 1 to infinity 1 plus 1 by n to the power n square. Solution. So what is the first step? First step, always write down un is equal to, here given un is 1 plus 1 by n raised to n square. Then what is the second step? Take to the power 1 by n. So un raised to 1 by n is equal to 1 plus 1 by n raised to n square to the power 1 by n. Then take this power inside. So it will be 1 plus 1 by n. 1 n gets cancelled. It is n. So simplification is over now. Then take next step, that is take limit n tends to infinity. So limit n tends to infinity un raised to 1 by n is equal to limit n tends to infinity 1 plus 1 by n raised to n. What is limit n tends to infinity 1 plus 1 by n raised to n? Now only we have discussed about these standard limits. So this is nothing but e. What is the value of e? It is 2.7. So 2.7 is greater than 1. So according to Cauchy's root test, if it is greater than 1, then summation un is divergent. Summation un is divergent. So conclusion is very important. We have to write down the conclusion clearly. As 2.7 is greater than 1, by Cauchy's root test, summation un is divergent. This is important. Now let us take next example. Okay, let us take next example. That is third example. Summation n is equal to 1 to infinity n plus 1 by n to the power n square into 1 by 3 raised to n. Then write down un is equal to un is n plus 1 by n square into 1 by 3 raised to n. Now raised to the power 1 by n. So this whole term raised to the power 1 by n. Then take 1 by n inside. So here first term n plus 1 by n raised to n square is there. N square into 1 by n, it is n into 1 by 3 raised to n into 1 by n, 1 by 3. So here if it is in this form, always write down it as, we can separate the terms. N by n is 1, 1 plus 1 by n. We have to write like this, because if we take limit for this, we will get a standard form. That's why we have to simplify. Is 1 by 3. Now after simplification, next step, take limit on both sides. So limit n tends to infinity un raised to 1 by n. So 1 by 3 is constant. We'll take 1 by 3 outside. Limit n tends to infinity 1 plus 1 by n raised to n. So this is again a standard limit. What is the value of limit n tends to infinity 1 plus 1 by n to the power n? It is e. So this is e by 3. That is 2.7 by 3. This is 0.9. 0.9 is less than 1. Then by Cauchy's root test, summation un is convergent. Summation un is convergent. So this is about module 3, about example 3. Now let us take example 4. Now let us take next example, that is fourth one. Summation n is equal to 1 to infinity 1 plus 1 by root n raised to minus n to the power 3 by 2. So it is un, I have written directly here. Un is this, and raised to the power 1 by n. Here also raised to the power 1 by n. Now we will take this 1 by n inside. So 1 plus 1 by root n minus n raised to 3 by 2 into 1 by n it is. Okay. So 1 plus 1 by root n minus, as it is, n raised to 3 by 2 minus 1 it is, because 1 by n is there. So it is 1 plus 1 by root n minus n raised to 3 by 2 minus 1 is 1 by 2. So again I can write this one as 1 plus 1 by root n minus n. N raised to 1 by 2 can be written as root n. Root n. Okay, n raised to 1 by 2 is root n. Again I will take this one, here minus is there. So I will take this down like this. 1 plus 1 by root n raised to the power root n. Because I can use here standard form. So I have taken it in the denominator. Now we will take limit n tends to infinity un raised to 1 by n is equal to 1 divided by limit n tends to infinity 1 plus 1 by root n raised to root n. So again by standard form its answer is E. So this is equal to 1 by E or 1 by 2.7 which is less than 1. Again by Cauchy's root test the given series is convergent. This is about fourth problem. Let us take next example. So problem number 5. Limit summation n is equal to 1 to infinity n plus 1 raised to n x raised to n divided by n raised to n plus 1. So this is un. I have taken here un raised to 1 by n. So this is un to the power 1 by n. Let us take 1 by n inside for each terms. So first one n plus 1 raised to n is there into 1 by n. It gets cancelled. So n plus 1. Here also x raised to n into 1 by n gets cancelled. X divided by n raised to n plus 1 into 1 by n into 1 by n. So this is n plus 1 into x. Here n raised to n plus 1 by n, or I can write this one as n plus 1 x divided by n raised to 1 plus 1 by n, because n by n is 1 plus 1 by n, or again it is n plus 1 x by n raised to 1 means n into n raised to 1 by n. Now I will take terms like this. So it will be x as it is n plus 1 by n into 1 by n raised to 1 by n. Just I am writing to use the standard forms. So x again here 1 plus 1 by n into 1 by n raised to 1 by n. Now take limit n tends to infinity, both sides limit n tends to infinity un raised to 1 by n. X is constant, x is free from n, so I will take x outside. Limit n tends to infinity 1 plus 1 by n divided by limit n tends to infinity n raised to 1 by n. So here x as it is, limit n tends to infinity 1 plus 1 by n is 1, and limit n tends to infinity n raised to 1 by n is also 1. So it is equal to x. So next, now we cannot write whether it is convergent or divergent directly. It depends on the value of x. So series summation un is convergent if x less than 1, and summation un is divergent if x greater than 1. So suppose our answer is x, you have to write down the conclusion in this form, because we don't know what is the value of x. We have to write down both the answers. That is, it is convergent if x less than 1, it is divergent if x greater than 1. And summation test fails if x is equal to 1. All three you have to write. Okay, next problem 6. Summation n is equal to 1 to infinity n plus 2 by n plus 3 raised to n x raised to n. So here we have to take to the power 1 by n, then we will get n plus 2 by n plus 3 into x. Okay, so here we cannot put directly limit. For that one, in the numerator I will take n outside, then in the inside I will get 1 plus 2 by n into x, and similarly in the denominator also I will take n outside, then it is 1 plus 3 by n, then n gets cancelled. If you take limit n tends to infinity of this term will be 0, I will get 1, limit n tends to infinity of this term, this will be 0, I will get x. So as in the previous problem, we have written conclusion. Similarly, we have to write x, if x less than 1, then series is convergent. If x is greater than 1, series is divergent, and test fails if x is equal to 1. See here, one different example is there. They have not given general form, but they have expanded it, and it is in the expanded form. Then we have to write down general form of that. Just see here, in the numerator 3, 4, 5, 1 increasing it is. So if I take here n plus 2, if I put n is equal to 1, I will get first term 3. If you take n is equal to 2, I will get second term. If you put n is equal to 3, I will get third term. Then denominator, it is 1 more than this that is n plus 3. Next, to the power is there. Here it is to the power 1, to the power 2, like that. So if I put to the power n, then x is there, x raised to 1, 2, 3. So x raised to n. In this way we have to write general form. Just substitute here, n is equal to 1, I will get first term. If you put n is equal to 2, we will get second term. If you put n is equal to 3, we will get third term. So this is similar example. Both are same, but they have given here general form. Here series is given, we have to write the general form. Next, this example, summation 1 by log n to the power n. So un raised to 1 by n, then n gets cancelled, I will get log n. Log n can be written as a log n to the power minus 1. If you take limit n tends to infinity, we know that limit n tends to infinity of log n is 0. So answer is 0, which is less than 1. So series is convergent. Thank you.